Okay. Starting trick today. Oh boy. Hopefully you guys are excellent at trig. Are you good at trig? I will teach you to get it.
Yelled at us for not knowing how to do it.
And then when I drew it out on my test, you would get mad at me for drawing it out and then
Bad
on the
grades.
test.
I don't care how you do it as long as you get it done. I would love for you to just know the unit circle back and forth and be able to jump to anything unit circular. So for example, if I said tangent of 5 pi over 6, go. Would you tell me?
No.
That's wrong.
That's wrong.
Alright, so we definitely get there. We will get there starting today. No problem. It's fine. So we'll be there. Yes, I will teach you the unit circle. Okay, so first of all, what is a radian? Actually, let's go back and do a question you might be better at. What's a degree? Where do degrees come from? Circles, true. Angles, true. But why this much? Why 360? It's not like it was, it's just there in the dirt and somebody's saying, hey, look at that circle. I mean, they made it up. How? Why 360? Well, 360 is terrible. Right? So it started off with people, they thought the ancients, 4,000 years ago, Sumerians thought there were 360 days in a year. So for that reason, degrees are terrible, because it's all based on 1,000, 360 days in a year. After that, the Babylonians, idiots that they are, they went base 60. Their number system was based at 60. What's your base? What's your number system? Base 10. Their number system was base 10. Their number system was base 60. And they did 60. First, the Sumerians did 24 hours a day, and then their hours were not equal. 60, then 60 minutes to an hour, 60 seconds. All that stuff was based on these terribly antiquated ideas. And so degrees are terrible. They're all based on terrible, wrong ideas. Radians actually make sense. I know you are going to fight me on this. Oh, I hate radians. Used to degrees. I hate radians. Radians make sense. Now, what is a radian? Where does a radian come from? First of all, it's got to be mastered by calculus. It wasn't created for calculus. It's created for review. All calculus is going to start. Somebody call an ambulance. Don't really. Dang it. Excuse me. All right, so a radian is the idea that if in a circle you made an angle that was just big enough so that if I think we had talked about this last week, but if I made a string this long, a radius long, the arc that it makes would be a radius long. That's also the idea where pi comes from, but that whole idea of the angle it takes to make an arc equal to a radius, that's a radian. It's the central angle of a circle that makes an arc 1 radius long. Now, 1 radian, just because we're so fixated on degrees, a radian's about 52, 53 degrees. Okay? So if I say, hey, how many radians is that? Take that in your mind, okay? Because you are so well grounded in degrees at this point. But a radian's about 52 degrees-ish. But for tons of math problems, radians are so much better. All right, now, we talked last week about how in terms of how many radii, we could get 1, 2, 3, 4, 5, 6, and a little more. We could actually get 3.14 diameters, but about 6.28 or 2 pi radians. Each of these arcs is a radius, so each of these angles is a radian. 2, 3, 4, 5, 6.28. So there are 2 pi radians in a circle. Now, if you just have all of these down, all your other trig will be super duper easy, all right? So if 360 degrees is 2 pi, then 180 degrees is pi, 90 degrees is pi over 2, 30 degrees is, think 180 degrees is pi, so 30 degrees is 180 degrees divided by 6, so each pi over 6 is 30 degrees. 45 degrees is pi over 4, think half of 90 degrees is half of pi over 2, so that's pi over 4. And 60 degrees, well that's 180 degrees divided by 3, so it's equal in radians to pi divided by 3. So let's take a second to get those deeply ingrained in your brain. Anytime I say you see a 2 in the denominator, pi over 2, then you should think multiple of 90 degrees. If I say pi over 6, think multiple of 30 degrees. So if I said 5 pi over 6, that's 5 30 degrees, and so it's 50. I'm going with the assumption that you can multiply. Are we good? Okay, so when I say pi over 3's, you think 60 degrees. So 4 pi over 3 would be 4 60-degree angles, so 40. If I say pi over 4, you should think every time it's pi over 4, it's 45 degrees. So if I said 3 pi over 4, that's 45, 90, 135, right? All right, so these are the basic building blocks that you have to have down cold. After that, then, it goes to just doing a little bit of counting. Do you agree 135 degrees is some kind of 45-degree multiple? Yeah? How many 45 degrees is it? 3. It's 1, 2, 3, pi over 4. Remember, we always start at the positive x-axis. Negative 240. Oh, sorry, it says label the reference angle. What's the reference angle? If that's 135 degrees, then what's this angle in the triangle? It's a 45-degree angle, okay? Okay. What about negative 240 degrees? You could actually think of that in terms of 30-degree angles or 60-degree angles. What do you want to do? 60-degree angles. How many 60-degree angles is 240? 4. All right, so if each 60-degree angles is a pi over 3, then this is negative 4 pi over 3. Yeah? All right? In terms of graphing, what does a negative mean? It means from the x-axis you go the opposite way, down instead of up. All right? Positive, negative angles mean go down from the x-axis. Positive angles mean go up from the x-axis. So the first one we went up from the x-axis. Negative angles we went down from the y-axis. Use the axes as a guide. That's 180. That's 270, so it must be in here. Do you agree that the reference angle is a 60-degree angle past 180? Do I ever draw to the y-axis? Notice I made a 60-degree angle with the x-axis. Can I also make a 30-degree angle with the y-axis? No, you never draw to the y-axis. You always draw to the x-axis. All right, so you should always be making your triangle in reference to the x-axis. It's a 60-degree angle with the x-axis is the reference angle. All right? 7 pi over 4. What's every pi over 4? 45 degrees. So we're going to go 1, 2, 3, 4, 5, 6, 7. So it goes whoosh, 7 pi over 4s. That's not as easy. And wouldn't you agree that the angle with the x-axis is a 45-degree angle? Yeah? In terms of how many, 5 over 4 is 45, so 7 45-degree angles. What's 7 times 40? 280 and, what else did I say? 40, oh, and 5 times 7 is 35, so 240, I'm confusing myself. 280 and 45 is 215. Okay. I did 270. Did I? Wait a second. Let's just start. So 280, sorry, I see. 280 and 45 is 280 and 35 is 315. Jeez. We'll be making it work. Okay. Wouldn't it be easier also to just say 45 from 360? Maybe that would be easier, yeah? 5 pi over 6. What's every pi over 6? 30 degrees. So 5 pi over 6. This is 5 30-degree angles, which is 150. So if I go 150, what's the related angle here? 30 degrees. Okay? And negative 4 pi over 3. Every pi over 3 is 60. So negative 4 pi over 3 is negative 60. Actually, I've already done this one, haven't we? That is negative 240. So we go down. And what's the related angle or the reference angle in the triangle? 60. Okay? Notice that your triangles should look good. In other words, a 30-degree angle should be a smaller angle. I don't want every triangle looking like a 45, 45, 90. A 30-degree angle should look bigger or smaller than a 60-degree angle. Please. All right? Now let's go to radians and degrees of all these variables. So let's start with degrees. 0. What's the first reference angle in the triangle? 30. Okay, and then 45, and then 60, and then 90. Okay, and then excellent. 120 degrees. 80, excellent. 210, 225, 240. Some of you guys have this down cold. 30 degrees more. 300, 315, 330, and this is also, I suppose, 360. Okay, cool. Now let's do radians. All right. So, 30 degrees. We could do this a couple different ways. We could do this by counting. One way to do this is by counting. Every 30 degrees is a pi over 6. Do you agree? And so I could go, here's 1 pi over 6. 45 is not a 30-degree angle, right? 60 is the next 30-degree angle. So that's 1 pi over 6, 2 pi over 6, but what is 2 pi over 6 reduced to? Pi over 3. 3 pi over 6, what is that reduced to? 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 reduces to nothing. Are you with me? So you could just count up by pi over 6. Is every 30-degree angle, say it's some kind of pi over 6 and reduce it if necessary. That's one way to do it. Another way to do it is just to take each one and count out how many. So 45 degrees, for example. Let's do 45 degrees. How many pi over 4s is that? 1 pi over 4, 2 pi over 4. What about 135? Yeah, count 45 degrees. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 is 270 degrees, yeah? Does that reduce? Yeah. So that's 3 pi over 2, and then 315 is 7 pi over 4s. All right. And so let's see. Let's do what I'm missing. 210 degrees. What is it in radians? 7 pi over 6. We know 210 is a multiple of 30 degrees. It's 7 30-degree angles, and so it's 7 pi over 6s. What about 240? It's like a number of 60-degree angles, right? How many 60-degree angles? 4 pi over 3. Each 60 degrees is pi over 3. So what about 300? It's a multiple of 60 degrees. How many 60 degree angles? 5, and each 60 degrees is pi over 3. So it's 5 pi over 3. What about 330? It's a multiple of 30 degrees. How many 30 degree angles is it? Pi over 6. Now, okay, so let's see here. Looking up from your paper, 5 pi over 6, how many degrees? 150. Pi over 4, how many degrees? 45. 3 pi over 4s. 135. 7 pi over 4s. 315. All right, we'll get there. We'll get there. We'll practice. All right. Now let's talk about how big the sines and cosines are in these. In Algebra 2, you started by using reference triangles that had nothing to do with the unit circle. And so they would say, here, there's the basic reference triangle for 45, 45, 90. It's 1, 1, and by Pythagorean theorem, it'd have to be root 2. Do you agree it's got to be 1 and 1 because if both sides are equal, both angles are equal, both sides are equal, yeah? So the root 2 comes from Pythagorean theorem. Now in unit circle, we focus on, first of all, why circles? Well, in the unit circle, every one of these is a radius, yeah? And so in the unit circle, every hypotenuse has to be one unit. That's why they call it the unit circle, because the radius is one unit. Now, I can't then put this triangle on this because the radius would actually be too long. It would be root 2. So when we do this in trig, we actually do a little bit of tweaking it so the hypotenuse is always 1. Now, if we do that, then by similar triangles, this has to be root 2 over 2 long. Let's square root of 2 long. It's about 1.4, all right? So square root of 2 is about 1.4. So let's square root of 2 over 2. It's about, hello, 0.7, yeah? Right, so think 2 smaller legs and a hypotenuse of 1. Square root of 2 over 2. Now in the reference triangle in geometry, or in algebra 2, the reference triangle for a 30, 60, 90 was 1 for the smallest leg, 2 for the hypotenuse, and by Pythagorean theorem, root 3 for the longer leg. People always want to put the 3 in the hypotenuse because in their mind, thinking too quickly, they think 3 is greater than 2. But it's square root of 3, which is about 1.8. So 2 is the longest side, the hypotenuse. Again, no, that has a hypotenuse of 2. On the unit circle, I can't have a hypotenuse of 2. I want to shorten up so the hypotenuse is 1. Well, if this is 1, then wouldn't you say scale factor-wise we half the hypotenuse? And so what's the shortest leg? 1/2. Oops. 1/2. And what's the longer leg? Root 3 over 2. All right. So in terms of the coordinates, all of this circle is the reference triangles with the radius of 1. So in terms of this point, if the hypotenuse or if the radius is 1, then what's the x, what's the y? The x is 0 or the y is 0? The x is 1 and the y is 0, okay? Now, look at, as we do these triangles here, this is going to be key when we go to graph this. Look what happens to the red side. It starts really long, and it gets a little shorter, and a little shorter, then a little shorter until it goes to 0. In the 30, 60, 90 triangle, do you agree that's a 30, 60, 90? What's the long leg? Root 3 over 2, and what's the shortest leg? 1/2, okay? And a 45 and a pi over 4, 45, 45, 90. What's the legs? What are the legs? Root 2 over 2, root 2 over 2. In a 60-degree angle, what's the longest, or the short side? The x is short now. The sides are 1/2 and root 2 over 2. So which one is the shorter? 1/2, and the longer is root 3 over 2 until I go straight up, in which case the whole radius is going up. So the x is 0 and the y is 1. Now look at the x's. Wouldn't you agree that as we turn, the x's get smaller and smaller and smaller, and the y's get bigger and bigger and bigger? Yay? Okay. Then we start to do the exact same thing, but switch signs. So now, in terms of symmetry, what's the the short side of the triangle? 1/2 or root 3 over 2. 1/2 and root 3 over 2. Notice it's just like the one across from it, but in terms of signs, what sign do I have to attach? Negative, yeah. All right. At the pi over 4, or the 45-degree angle, it's the same as on the other side, root 2 over 2 and root 2 over 2, but in terms of sign, the x is negative. At 5 pi over 6, it just looks like the 30-degree triangle in the first quadrant, so it's root 3 over 2, 1/2, but the x is negative. And at 180 degrees, or pi, the x is 0. All right? Now we're going to have those same values. It's still a 30-degree angle, so the reference is long root 3 over 2, short 1/2. But what about the signs? Both negative. Okay? Now it's a 45-degree angle. The x is root 2 over 2, the y is root 2 over 2, but signs are both negative. And a 60-degree angle. The shortest side is 1/2. The longest side is root 3 over 2, but both negative, until at 270 degrees, which is how many radians? 2 pi over 2, 2 pi over 2, 3 pi over 2. What's the x? What's the y?
0, negative.
0, negative 1. Okay. And last but not least, this guy, it's a 60-degree angle, which means a small x, longer root 3 over 2y. X positive or negative, y positive or negative. Positive x, negative y. What is the next point you come to? Root 2 over 2s in both cases, and the signs positive, negative, and here. Root 3 over 2 is the longer side now, x is the longer side, y is the shorter side, and the sign again is negative y. All right. Now, the first level of skill on this is to be able to do the circle around, and then later we'll be able to jump around to mixed facts, and we'll get there. All right? So, cosine of 135 degrees. So, for cosine, what is cosine again? SOHCAHTOA. So ka is adjacent to hypotenuse, yeah? And the adjacent side in any triangle is the x side. So when you do cosine, you should be thinking x over 1, because the hypotenuse in the unit circle is always 1. So in terms of xy relationship, think x over 1. The reference triangle for a 45-degree angle is root 2 over 2, root 2 over 2, 1, yeah? And the sign, cosine is x, x is negative in that quadrant, and so what do we say, positive or negative? Negative. And so what is our final answer? Cosine of 135 is negative root 2 over 2 over 1. Remember, cosine is just the x with the sine. Cosine of 45 degrees is root 2 over 2. So with appropriate sign, it's negative root 2 over 2. You with me? 210 degrees, or tangent of 210 degrees. Tangent is total. Opposite over adjacent. Where in a triangle, the opposite is always the y side and the adjacent side is the x side. So in terms of xy relationship, tangent is always the y, the opposite side, over the adjacent side. In this triangle here, it's a 30, 60, 90 reference triangle, yeah? What's the longest leg in the 30, 60, 90? That's true. The longest side is 1. That's true. What's the longest leg? 3 over 2, and the shortest leg? 1/2. All right. So in terms of the, we'll come to that in a second. So in terms of the sign, aren't these both negative? Yeah. All right. So now we need to put all this together. We need to get the appropriate sign and the appropriate ratio. So in this picture, what's the y? -1/2. What's the x? Oh, sorry, not negative. Sorry, I'm confusing myself. What's the sign here when I take negative over negative? Positive, sorry. I should maybe do this. Negative over negative is positive. So I have a -1/2 over a negative √3 over 2. The negatives cancel. The 2's cancel, so I get 1 over √3. But then we typically rationalize it. Do you remember what the rationalized form of that is? √3 over 3. Okay, cool. Sine of 5 pi over 6. Sine is opposite to hypotenuse, and the opposite is y. The hypotenuse in the unit circle is always 1. 5 pi over 6, what kind of reference angle? 30 degrees, 45 degrees, 60 degrees? 30 degrees in what quadrant? Right there. So it's like 150, so it's in the second quadrant, yeah? The sides are 1/2 for the opposite and -√3 over 2 for the adjacent. Now the quadrant signs, what's the y in that quadrant? Positive, and the hypotenuse is always positive. The hypotenuse is always positive. And so that's a positive sign value. Last but not least, the ratio. What's the y value over 1? Sine is y over 1. The y is 1/2 over 1. And so, just 1/2. All right. Cosine of -2 pi over 3. Cosine of -2 pi over 3. What's cosine? X over 1. -2 pi over 3. Each pi over 3 is how many degrees? 60. So -2 pi over 3 is 2 60-degree angles, so -120. Wouldn't you agree then that if I have a angle drawn up to the x-axis, I have a 60-degree angle. If it's 120 degrees here, then it must be a 60-degree angle there. That means this is the longer leg, which is √3 over 2, and it's negative. This is the shorter leg. It's 1/2, and it's negative. What about x over 1, and what's the sign? What's the x there? Is cosine positive or negative there? It's negative because x is negative, yeah? And what is your final answer then? If I take the x over 1, it's just -1/2. Sine of -90. What sign? Ratio? Y over 1. Okay. 90 degrees, is that up or down if it's negative? Down. Okay. And sine, which is y positive or negative down there? Negative. And what is the sine of 90 degrees? The y is -1 over 1, and so altogether then -1. Tangent is opposite over adjacent, or y over x. 7 pi over 4. What's every pi over 4? What kind of angle? 45. So if I go 1, 2, 3, 4, 5, 6, 7, it puts me all the way over there in the fourth quadrant. in that quadrant, what's the sign of y, what's the sign of x? Y is negative, x is positive, so overall sign is negative. All right? In that quadrant, what's the reference triangle has sides that are equal? Do you agree? Root 2 over 2 and root 2 over 2. So if we did y over x, and they're the same values, then that's 1 with what sign? Negative. All right. Now then let me explain what I would like to see in terms of work when you do these on the homework. I would love for you to have the right reference angle in the right quadrant shown. So a picture, I expect a picture. 11 pi over 6 is what quadrant and what reference angle? Fourth quadrant with a 30-degree angle, wouldn't you agree that that's 11 30-degree angles? That's 330 degrees. And so that's just 30 degrees shy of 360 degrees. And long leg in a 30, 60, 90? Root 3 over 2, the short leg. 1/2. Now, opposite sign is y over 1, yeah? So if you take y over 1, what do you get? The y is negative 1/2 over 1 is negative 1/2. Sine of pi over 6 is 30 degrees. Sine of 30 degrees, it's 1/2 with a negative sign. All right, what about tangent of negative 4 pi over 3? What kind of angle and in what quadrant? What related angle or reference angle, what quadrant? 45 degrees in what quadrant? 45? What's pi over 3? 60, okay. So 60 degrees in 4 of them is 240 degrees negative, so that's here. So we should have a 60-degree angle. Again, it shouldn't look lame and like an isosceles triangle. It should look like you're showing the bigger angle, 60-degree angle. The shortest side is 1/2. The longest side is root 2 over 2. Signs are negative on the x, positive on the y. Tangent is opposite over adjacent. So what is the opposite over adjacent ratio? We'll simplify in a second. What's the opposite to adjacent ratio? Root 3 over 2 to negative 1/2. Simplified, what is that? All right. Okay. I could have done a better job of explaining that, but we'll practice it a lot. Don't worry. If you're just saying, I don't feel much better than before, you will. You're going to get math. My goal is that by the time I'm done with you, you should be able to do 10 mixed trig facts in a minute. Sorry, 6 seconds, 6 trig. We'll practice until okay? Alrighty. This, huh? You thought I was going to forget to do
I didn't know how
Hi. Oh, you're taking another college?
Yeah.
You like your brother?
Yeah.
That would be hard for you, I'm sorry. Are you in step?
What?
Are you in step?
Yeah.
Oh, cool. So when is this? This is
Thursday and Friday.
Thursday, Friday. Alright. I will record the lessons each day and post them at the end of the day, and I might be able to get you the homeworks ahead of time if you don't mind.
Okay.
Today's Okay, there you go.
Thank you.
You're welcome.
That wasn't, I didn't do a very good job.